All right, hello everybody. This is Miss Piekarski. Hopefully you are behaving for the sub. So for first period, I just wanted to go over page 132, problem 6, letter B and letter D. With these problems, you needed to use your quadratic formula and find all your solutions. Okay, most of you have used the quadratic formula before. If you don't remember what it is, look at the back of my classroom. On the back wall, there's the quadratic formula up on the poster board. All right, so let's go ahead and get to this. So we have this quadratic equation, and the first term that we need is a negative b value. And notice that our b is already negative, so we have a negative 9, and then plus or minus negative 9 squared, and then, the square root of negative 9 squared minus 4 times my a value times my c value. And notice how I have the negative on the c value. I have my negative 18 there as well. Also notice it for my negative 9 here, it is in parentheses when I square it, so that I will have a positive number when I set it in my calculator. All right, and then in the denominator, you just have 2 times your a value. In this case, our a value is 2. Okay, I know most of you would love to be able to plug this into your calculator and just find your answer. If you were able to set everything in the calculator correctly, you probably could do it, unless you get a irrational number. Basically, any irrational number is a number that has a decimal that's going to keep on going forever. Okay. Also, notice you have this plus and minus sign here. Frequently, I have students ask me, where is the plus and minus button on the calculator? You can't just plug in plus and minus at the same time. If you were going to plug all this in your calculator, the first time you would do it, you would use the plus sign. The second time, you would use the minus sign. However, I want you to get in the habit of not plugging it in the calculator, to just simplify in stages. Okay, to do that, first of all, negative times negative 9 gives you a positive 9. And then you have negative 9 squared is 81. And then if you multiply all these together, you get 144. And then in the denominator, you just have 2 times 2 just gives you 4. Okay. You can keep on simplifying it, add the 81 and the 164 together. That gives you 225 under the square root symbol. Go ahead and see if you can get what the square root of 225 is. And you end up with, I think, 15. Yeah. Square root of 225 is 15. Now, if you have a square root and it's not giving you a nice whole number, then go ahead and leave it in the square root symbol. Okay, in this case, we do get 15. So now we have 9 plus or minus 15 and then divided by 4. At this point, go ahead and split up your fractions into 2 different equations. One of them will have a plus sign and one of them will have a minus sign. Okay, and then simplify from there. So 9 plus 15 gives you 24. Divided by 4, and then 9 minus 15 gives you negative 3 divided by 2, negative 6 divided by 4. You can go ahead and simplify these further. Let me see if I went ahead and simplified them. Let me see. No, I didn't. You can simplify this further. 24 divided by 4 just gives you 6, and negative 6 divided by 4 gives you negative 3 over 2. Let me see if I can do a better 3. There's my 3 divided by 2. Now, I know most of you do realize that you can convert that to a decimal and you get negative 1.5. Okay? All right, so notice how this fraction, if you simplify it, this is an ending decimal. In other words, it doesn't keep on going forever. If you have a situation like that, and you want to convert it to a decimal, you can. But I would actually prefer you to leave your fraction as a fraction, okay? If, let's say, instead of 3 over 2, let's say we had 2 over 3, okay? And you try to convert it to a decimal. Hold on, let me see. Get there. There we go. Oh my gosh, this is driving me crazy, trying for that box. Okay, so if you try to get a decimal, 2 over 3 gives you, actually it should be 0.666. Okay, sorry, I messed up there. That should be 0.6. Let me cross that off. 0.6, and it just keeps on going, right? It's going to keep on repeating forever and ever. Okay, if you gave me 0.6 repeating, I would mark it wrong, okay? Go ahead and leave it as a fraction. So let's look at D now. Notice on D, you don't see a B value. Your B value is actually 0. And if you wanted to use your quadratic formula, you could. However, it would actually be easier to use, to just set your equation equal to 0 and solve for your x value. So if you do that, the first thing you get is x squared minus 5 equals 0. And then you move the 5 over by adding 5 to both sides. So you have x squared equals 5. And then to get rid of the squared, you have to square root everything. And anytime you square root something, you always have a plus and a negative value. And in this case, the answer would be positive or negative square root of 5, and or. All right, so notice if you plug in the square root of 5 into your calculator, you'll get a whole bunch of decimals. In that case, do not give me a whole bunch of decimals. Just write your answer as positive square root of 5 and negative square root of 5. Okay, over here your answers were 6 and negative 3 over 2, so those are your two solutions here, and for D, those are your two solutions. Now, on the instructions on the paper on the board, it tells you that you need to do 3 of these. I just did 2 of them with you. I want you to do 3 more. Okay? All right, so now let's look at problem 5 on the same page. I just wanted to remind you that now that you know how to use your box method, I want you to find the polynomial in standard form. In this case, you only have 3 factors. So the first thing you want to do is multiply these 2 factors together with the box method, and then whatever your answer is from these 2, multiply it by x plus 1. Okay. On D, you're going to do pretty much the same thing we did yesterday. You're going to use the box method 3 times. Multiply these 2 terms together, multiply these 2 terms together, find your answers to both of those, and multiply your answers together. All right, moving on. This is on page 133, problem A. Now on this one, it just says find the real zeros for the following polynomials. And honestly, to do this, all you would need to do is graph your polynomial and find your x-intercepts. If you have whole value x-intercepts, you just look at your graph. In this case, your x-intercepts are at -3 and +3. Okay, but if you look at the equation, it's x raised to the 4th power. So you should have 4 solutions to this, but you only have 2 x-intercepts. And you can see from the graph that neither of these x-intercepts are have a multiplicity of 2 because they cross the x-axis, which tells you that your 2 other solutions are going to be imaginary solutions. And I know that this says just to find the real zeros, you don't have to find the imaginary, but I'm just going to tell you what the imaginary solutions are, and then I'm going to show you how you can multiply all your factors together with the box method, and you'll get the same polynomial equation. All right, so for right now, I know that one solution is at -3, one solution is at +3. For right now, I'm just going to tell you what your imaginary solutions are. On Friday, I will show you how we found those imaginary solutions, but for now, these are the other 2 solutions. So I have -3, +3, -3i, and then +3i. Okay, once you have your solutions, the way you would set up your factors, okay, the first factor is -3, so it would be x minus -3. Well, if you're doing minus a negative number, it's just going to become a positive number. So this negative 3 creates a factor x plus 3. This positive 3 would end up being x minus 3. And then this 3i would become x, it should be positive 3i. I messed up the order on here. So this negative 3i would create this factor x plus 3i, and this positive 3i would become x minus 3i. So notice on for your solutions, these are all your solutions, and when you're setting up your factors, you just change your signs to set up the factors, okay? So now if we wanted to multiply all these together to verify that the polynomial equation is x to the 4th power minus 81, I'm going to use my box method. I'm going to take the first two terms, put them on my columns, or the first term, put it on the column headings, the second term factor, put it on the rows, and then I'm going to multiply everything together, and I get x squared here, 3x here, negative 3x here, and negative 9. Okay? So that's when I box these two terms together. Now I'm going to box these two terms together. And again, x is in first column, 3i is in this column, x is over here, and negative 3i is over here. When I multiply all those terms together, x times x gives me x squared, x times negative 3i gives me negative 3ix, and 3i times x gives me 3ix. Okay, when you are combining like term, my fourth box. So this one, 3 times 3 gives me 9, the negative's still there, and I times I gives me just I squared. Okay, so when you combine all like terms, you have x squared, these two terms cancel out, and then you can go ahead and simplify this. The way you're going to simplify it, what you actually have, let me delete this, the negative 9 times I squared, well, negative 9 can stay negative 9, and then I squared actually equals negative 1. If you're not sure, just look on the back of the room. I have a poster that says I squared equals negative 1. Okay, so, and then you can multiply these two together and you just get a positive 9. So when we are multiplying our solutions here with the solution here, what we end up getting is we have x squared minus 9 from this one, and then over here we have x squared plus 9 from over here. Okay, when you factor all those together, those are the terms you get. Okay, when you combine like terms, your two middle terms will cancel out, and you're just left with x to the 4th power minus 81. I forgot my minus sign here. I have my minus 9 here. I just forgot the minus sign there. Let me go ahead and draw it in there. Okay. There we go. There's my negative sign. And then, so we're back to the same original polynomial in standard form. All right. So hopefully you wrote all this down. Have this posit so you can see, write it down again if you need to. Let's go ahead and move on. Let's look at problem 9. This is on page 133. Here you have, what is a polynomial function that could have the zeros at x equals negative 3, negative 2, and 1. So again, you're going to set up your factors. So the x equals negative 3 is going to create the factor x plus 3. And then this negative 2 is going to create the factor x plus 2. And this positive 1 here will create the factor x x minus 1. Okay, so there is your polynomial. Now, is this polynomial unique? In other words, could you have another equation that will have those same x-intercepts? Well, yes, you can. One option is if you have a leading coefficient that's some number other than 5. That will give you the same x-intercepts. It's just going to stretch where the minimum and maximum points are. All right. Another thing that you can change is if you squared any of your factors, you would still have an x-intercept. Like if we squared x plus 3, then we'd still have an x-intercept at -3. It would just be a double root. In other words, it would hit the x-axis and bounce off. Okay, so you can change your leading coefficient. You can square any of these terms. There's a lot of ways to find another polynomial with the same x-intercepts. Okay. Problem 10. Yeah. All right. So for number 10, you have zeros when x is 3 and x is -1. Remember, zeros is another word for x-intercepts. This is just one example of where I have an x-intercept at -1 and at 3. I don't know if it's a quadratic function, but this is just an example. If the function is shifted 4 units to the left, what are the new zeros of the transformed graph? Well, if we move it 4 units, we have to the left, it's 1, 2, 3, 4 units, and my x-intercepts are now at let's see, 1, 2, 3, 4, 5. So at -5 and -1. Okay, super easy to shift it over and figure out your x-intercepts there. Okay, let's look at this. Let's see. All right, page 134. I'm trying to remember what problem this is. What are we doing? Oh, you want to find all your x-intercepts or all your solutions, and the instructions in your book tell you to group your terms and then simplify whatever you can simplify. There are instructions in the book. Go ahead and look over those in your own time. Hopefully, if this is confusing, what I'm doing up on the board, then read the instructions. It might be a little bit more helpful. Okay, so notice right here we have our degree here is 3, so we can't just use your quadratic formula. And also notice that my terms are in the wrong order. The correct order would have the first term would have the highest degree, then the next highest, next highest, next highest. So these are all in the wrong order. Notice here I start off with a 4, then I have 3, and then 2. Okay, so because they're in the wrong order, the first thing you want to do is rearrange them so that everything is in the proper order. So when you rearrange it, you have 2 times x to the 3rd power plus x squared plus 8x plus 4. Okay, and I just changed the order. Now I'm going to group it. I want to group these 2 terms together and group these 2 terms together. So when I do that, I just have this situation. And notice how here I have both of these terms have x squared in it. This one would be x squared and then times another x. Okay, and then this has an 8 and a 4. Well, I can factor out my greatest common factor from both of these. So in this case, my greatest common factor would be x squared. So I'm just going to factor out x squared from this term, and I'm left with 2x plus 1. From these 2 terms, I can factor out a 4. So it'll be a positive 4, and then in the parentheses, I'm left with 2x plus 1. So notice that this factor, or this term here, is exactly the same as this term here. Anytime you have that situation, you can rearrange your terms by taking this term plus this term and setting that as one factor. And because these 2 are the same factor, that would be there. Okay. Now, to find all your solutions, you're going to set each of those factors equal to 0 and solve for x. For the first one, you're going to get 4, move 4 to the other side, so you have a -4, and that's going to equal x squared. And then this one, you're going to subtract by 1, and so you have 2x equals -1. To simplify this further, you want to get rid of your square root. And so you're going to have positive or negative square root of negative 4. And then over here, you're going to divide by 2. And here, this is the last thing you need to do is just divide by 2. And so you get your x is going to equal negative 1/2. Notice we have a negative sign here. And we're doing the square root of a negative number. So part of our solution, we are going to have an imaginary solution. And then the square root of 4 is just 2. So your solutions over here are going to be positive 2i and negative 2i. So for your 3 solutions are right there, okay? Problem C, these are all in the correct order, so we can go ahead and look for our greatest common multiplier. In this case, notice we have x squared, x cubed, and x to the 4th power. So the greatest common multiplier is going to be, oh, I forgot, set it equal to 0 and then solve for x, okay? Find your greatest common multiplier. Greatest common multiplier is going to be x squared. You can factor that out, and then you have x squared minus x minus 20. Notice for my terms, I just subtract 2 from each of these terms. So x to the 4th power becomes x squared, x to the 3rd power just becomes x, and then this just disappears completely. All right, so now I have x squared, but I also need to go ahead and factor this. If you can't remember how to factor without using your quadratic formula, you can go ahead and use your quadratic formula, but this one is fairly easy to factor because I have a negative sign here. I know that one of my factors will have a minus sign and one will have a plus sign. I need 2 numbers that multiply together to get 20 and add together to get a negative 1. So 5 times 4 gives me 20. And if I have a negative 5 and a positive 4 and I add those together, I get negative 1. So those are my factors. Now when I set up my solutions, I'm going to, this x squared will give me a 0 for a solution, but because it's squared, I actually get 2 zeros. And then this factor gives me a 5 for my x-intercept, and this factor gives me a negative 4. Okay, don't forget, anytime you have squared terms here, that just means you're going to hit the x-axis and bounce off. Okay, and then my other 2 x-intercepts are at negative 4 and 5. All right, moving on. Let's see. I think you have to do the other. All right, so these are from Try These A. I want you to do A on your own, and then I think problems 14, 15, 16, 17, 18, something like that. Let's look at it. Let me see. All right, so 14 and 15, they just want you to, let's see, graph the following function. Try to graph it without using your calculator, okay? And I want you to draw a graph on a separate sheet of paper. And I also want you to multiply all these terms together to get your polynomial. Remember, this x minus 3 squared would be x minus 3 times x minus 3. X plus 2 squared is x plus 2 times x plus 2. And the same thing for x plus 4 squared would be x plus 4 times x plus 4. So you actually have 6 factors you need to multiply together. You're going to have a lot of boxes. Use the box method. All right. Last thing we're going to look at, also on page 134, problems 16, 17, and 18. I want you to work on those. These ones are going to be very similar to the Try These A that we just did up here. Okay? So work on those. You have the rest of the class period to work on this. Anything you don't get done in class today is going to be homework, and all this stuff is due Friday. All right. If you need the sub to rewind the video, go ahead and ask her to do so. And I will see you guys Friday.